The remainder of standard 19 focuses on using u-substitution to help us integrate composite functions. And after you practiced your derivatives a moment ago, we understand that composite function is being made up of two different functions, an inner and an outer, functions within functions. The chain rule says that the derivative of f of g of x, a function within another function, is given by the product of each of those two derivatives. So take derivative of f, multiply it times the derivative of g. Sometimes we use u-substitution to work with that. So now write that in terms of u by letting u equal the inner function g of x. If I let u be given by g of x, I can replace g of x with u. So the derivative with respect to x of f of u, where u is used in place of g of x, that's going to be equal to f prime of u instead of g prime of x. Since u is equal to g of x, that's simply just u prime. Using the u-substitution, represent the inner function. You just practiced that. Let's relate this to antiderivatives. How is the derivative and antiderivative related to each other? Derivatives versus antiderivatives. What have we talked about them so far? Why are they related to each other? They're opposites. So if the derivative works one direction, I can reverse it to talk about the antiderivative, right? The antiderivative of this right-handed portion, the antiderivative of f of g of x times g prime of x dx is going to be equal to, capital F of g of x plus c, where capital F is the antiderivative of function f of x. Taking the antiderivative of a composite is just the opposite of using chain rule. Rather than taking the derivative of a composite to produce this function, since the antiderivative is just the reverse of that, the antiderivative of this composite function would be capital F of g of x plus c. Capital F is the antiderivative of function f of x. So what we typically do is what is called u-substitution, where I let u be equal to g of x. I replace g of x with a u-sub to put this in a better, easily antidifferentiable form. I'm going to rewrite my composite using the u-substitution to put it in a more antidifferentiable form. If u equals g of x, then the derivative of g of x with respect to x is given by du equals g prime of x dx. I replace g prime of x dx with this formula above by du. So therefore, the antiderivative of f of u du, derivative of f of u du, is equal to f of u, using u in place of g of x plus c. Antiderivatives of composite functions is just the complete opposite of the chain rule. It's working backwards. This is a composite function, f of g of x, function within a function. The antiderivative of f of g of x times the derivative of the inner function g prime of x dx. That's equal to the antiderivative of f of g of x plus c. Does that argument about working in reverse make sense? I'm taking this right side and making it the same as the left over here by using antidifferentiation. Then let's do this. Let's use this u-substitution technique to take antiderivatives of composites. switching around the chain rule. I want to evaluate this indefinite integral by finding the antiderivative of x squared plus 5 to the 6th times 2x dx. Why is this a composite function again? One more review on composite function. How would this be a composite? What does composite mean? Something's a composite. What does that mean? Functions within functions. What's the inner function? Squared plus 5. What is happening to that function? What's the other function? To the 6th. What we're going to do is we're going to let that inner function be equal to u. I can't take the antiderivative right now without working through all that expansion and multiplication. So let's take a shortcut. Let's use u-Substitution to find a better antidifferentiable form. U equals the inner function, x squared plus 5. The rest of my substitution is done by finding du. du is notation for the derivative of u with respect to x. du dx. Take the derivative of u with respect to x. So if function u is given by x squared plus 5, du dx would be the derivative of x squared plus 5 with respect to x. What's the derivative of x squared plus 5? 2x. Now what I'm going to do is I'm going to solve this for du. du is being divided by dx. So how do I get rid of dividing by dx? What's the opposite of dividing by dx? Multiplying, thank you. So I'm going to multiply both sides by dx, which cancels out the division on the left side. What's the dx over here? Where have you seen 2x dx inside this antiderivative? It's just this part right here. 2x dx is now given by du. Where have we seen x squared plus 5? Well, that's just the inner portion here. We'll let x squared plus 5 be given as u. Let's change the variables from x to now in terms of u using our u-Substitutions. The antiderivative of u to the 6th du. To me, I can take the antiderivative of u to the 6th in terms of u a lot better than this expression in terms of x up above. By rewriting using u-Substitution, it's now a whole lot easier. What's the antiderivative of u to the 6th? Good, Nora? Antiderivative. This means antiderivative. We're integrating. So bump up the exponent, Nora. We do the 7th. Don't forget the plus c. What needs to be out in front? An extra constant of what? 1/7. So there's my antiderivative in terms of u. The original function was in terms of x. So let's replace u to what it's equal to in terms of x so that my answer matches the variable that it was given, the variable form that it was given. What is u equal to? What did we define u earlier as? X squared plus 5. How could you check your work? The lovely thing about antiderivatives is that you can always check your work. How can I check the work of this antiderivative? No. And I should get back to what though? what I started with. I would just undo the antidifferentiation that I had previously done to the original function. We're going to do a million of these. They're all a little bit different. Let's see here. Let's do x 4x squared plus 1 squared. And take the antiderivative of x, quantity 4x squared plus 1 cubed, dx. This is a composite function, so we're going to attack this using u-substitution, where I let u be the inner portion of this expression. So what is u? What should we define u as? What's the inner function? You bet, Jamie. Let's let u be equal to 4x squared plus 1. That leaves me x dx to write in terms of u by using the du substitution. I'm going to take the derivative of what I defined u as in hopes of replacing the rest of this expression in terms of u. Take the derivative of u with respect to x. So u du equals, what's the derivative of 4x squared plus 1? X dx. We're doing derivatives, right? That's where this gets tricky, Caitlin. I'm having you do derivatives and antiderivatives at the same time. You take the derivative of your u sub, and then you anti-differentiate once you write it all in terms of u over here. So it can get real tricky real fast. All right, so what I've done, similar to this over here. I wrote du dx over here to start with. If you do du dx, you're going to have to multiply by dx every single time to solve for du. So what I usually do is I just put the dx over on the right side because I know it's going to go over there anyway, right? I take the derivative of u with respect to x. So that would be 1 du dx. The derivative of x squared plus 5 is 2x. But then I just move the dx over by multiplying it to both sides. The same thing here. I just know that I'm going to write this dx over on the right side every single time, so I can just skip that step. du is equal to 8x dx. I'm trying to replace this with x dx. How can I solve this for x dx? Because right now it's 8x dx. It worked out really nice over here when I had 2x dx. That's what was given by the rest of this expression. This doesn't quite line up so nice because it's x dx. I have 8 times that. So what can I do to adjust and solve for x dx? I want to get rid of this 8 so that better matches my integrand. Divide what? Divide by 8, right? And then multiply by 8, we can divide by 8 to cancel it out. Dividing by 8 is the same thing as multiplying each side by 1. 1/8. So let's just write this as 1/8 du equals x dx. So x dx, that's going to be 1/8 du. Instead of 4x squared plus 1 to the third, in terms of u, that's going to be u to the third. Instead of x dx, I'm going to call that 1/8 du. I'm going to write this integrand in terms of u. In from 4x squared plus 1 to the third, we wrote that as u to the third. Instead of x dx, I call that equal to 1/8 du. I kind of like to have the 1/8 out in front, but that's entirely up to you. What is the antiderivative now? Okay, while we're doing antiderivatives, make sure you're going the right direction. Mm-hmm. What is the antiderivative of 1/8 u cubed? After I've got it in a better antidifferentiable form, I can take the antiderivative. U to the fourth, I agree with you on that. It'd be u to the fourth plus c. If I take the derivative of this, it's 4u cubed. I need 1/8 u cubed. So what has to be out in front? What times 4 is an eighth? 37. Now when I take the derivative, I have 4u cubed multiplied by 1 over 32. 4 times 1/32, 4 is an eighth of 32, so that should line up right. Are we all done? There's one last step to do. What is it? Right. Should my variable for my final answer match the variable that I was given to start? I want to find the derivative. I want to find the antiderivative of this expression in terms of x, so my answer better be in terms of x. How can I make that happen? What is u equal to in terms of x?
4x.
So just back substitute 4x squared plus 1 for u. Final answer here for our antiderivative is 1/32 gesundheit. 4x squared plus 1 fourth plus constant c. Then a couple of algebraic questions. Let's try a trig question. We slide over here. Everybody can see. There we go. What is the antiderivative or indefinite integral of sine 3 theta d theta? Why is this a composite function? Well, we should be asking ourselves, what is the inner function in this expression? What is inside what? Is sine inside of 3 theta, or is the 3 theta inside of the sine? Right, the 3 theta is inside the sine. The inner function is 3 theta. The outer function is the sine portion. So when I set up my u-substitution, what do I assign u to be equal to? U is equal to what? What's the inner function?
Molly Comer, report to the secondary office. Molly Comer.
3 theta,
report to
got it.
the secondary office.
Now let's take the derivative with respect to theta. The derivative of u, we're going to call du. D is for derivative of u. That's equal to what? What is the derivative of 3 theta? 10 theta is like any other variable, like x. So 3 d theta. Right now I have the antiderivative of sine u d theta. What would d theta be equal to using this substitution step here? I know that du equals 3 d theta. So what would d theta be equal to in terms of du? How could I solve this expression for d theta? So or multiply by up there. Divided by 3 is the same as multiplying by up there. Looking at this part and this part, we can write my entire integrand, my entire antiderivative in terms of u and du. D theta is equal to 1/3 of du. 3 theta is equal to u. So when I write this expression in terms of my substitutions, I'll have the antiderivative of sine u times 1/3 du in replacement of d theta. I kind of like to have the 1/3 out in front of the sign, put the constant out in front, but that's entirely up to you. All right, we're going to take the antiderivative of sine. Now what's going to be cosine? Well, what constant do I have to have out in front? Derivative of cosine is negative sine. I want it to be positive 1/3 sine. Coefficient helps you get there. So, negative 1/3. More part to go. Now that the u substitution has accomplished what I needed to, I'm done with it. Done with the u. Let's put it back in terms of theta. What is this u equal to in terms of theta? My final antiderivative answer. U is defined to be what? Theta right here. So here we go. Negative 1/3 cosine 3 theta. Let's see. The online soldiers, the online people, what are your thoughts here, guys?